Throughout history, Canada has made a significant contribution to quantum physics. Many Canadian physicists have innovated technology and developed theories which have assisted in research and further discoveries. But how has Canada contributed to quantum physics? The two physicists that will be discussed in this video are Bertram Neville Brockhouse and William George Unruh. First, let's start off with Bert Brockhouse, who was born on July 18, 1915 in Lethbridge, Alberta. Brockhouse earned his master's degree in 1948 from the University of British Columbia in physics and math. He later on went to the University of Toronto, where he obtained a PhD in physics. But how did Brockhouse contribute to quantum physics? Brockhouse made contributions in neutron scattering by developing a new method called inelastic neutron scattering. Also by developing a technological innovation called the triple axis spectrometer. What is neutron scattering? In neutron scattering, a beam of neutrons is aimed at a target material, and the resultant scattering of the neutrons yields information about the material's atomic structure. Brockhouse developed inelastic neutron scattering, in which the relative energies of the neutrons give additional information. The triple axis spectrometer is an instrument used to obtain measurements of the scattering function at any point that is accessible by the spectrometer in energy or momentum space. The complete development of this was done by Brockhouse in 1958. Other than developing the inelastic neutron scattering method and the triple axis spectrometer, Brockhouse had contributions in inventing the constant Q method, beryllium filter detector, and finding new uses for the material pyrolytic graphite. However, after many years of research, Brockhouse wanted to transition back to academics, so he accepted a job of becoming a professor for the subjects solid-state physics and thermodynamics at McMaster University. He also wanted to open up a research program for the students at the university. Brockhouse won many awards throughout his lifetime, some of them including the Torrey Medal from the Royal Society of Canada, the Dudell Medal and Prize from the British Institute of Physics, and the Centennial Medal of Canada. Despite winning all those awards, Brockhouse's biggest achievement was winning the Nobel Prize for Physics in 1994, sharing the prize with Clifford Shull from MIT for developing neutron scattering techniques and studying condensed matter.
William George Unruh is a Canadian physicist. He was born on the 28th of August in 1945 in Winnipeg, Manitoba. Unruh began his post-secondary education in Canada in 1963 at the University of Manitoba, where he earned his Bachelor of Science degree. Then he moved to the United States of America, where he earned his Master's in 1969 and his PhD in 1971, both from Princeton University in New Jersey. Currently, he is a professor at the University of British Columbia. During his career, he has made pivotal contributions to society's understanding of a range of problems arising from quantum physics, gravitation theory, and cosmology. He is credited with developing concepts and tools such as the Unruh particle detector, the Unruh vacuum, Unruh temperature, and most importantly, the Unruh effect in 1976. The Unruh effect, in simplest words, is something that is accelerating in a vacuum or space will find itself in a thermal reservoir. A thermal reservoir is a hypothetical body that can supply or absorb finite amounts of heat without undergoing any change in temperature. Essentially, any object in space emits thermal energy as electromagnetic radiation, also known as black-body radiation, and it continuously loses energy until it achieves equilibrium. An example of this effect can be given by a thermometer being waved around in space, as it will record a non-zero temperature. The Unruh effect helps in space travel, as physicists can predict the effective temperature experienced by an accelerating space shuttle. This temperature is shown as Unruh temperature and is directly proportional to acceleration. Unruh discovered that for every increase of 2.5 times 10 to the power of 20 meters per second squared, the Unruh temperature increases by 1 Kelvin. Additionally, the Unruh effect has also greatly helped our understanding of quantum decoherence. Quantum decoherence is important for our understanding of quantum computing.
Created using Powtoon.